Hi class, we are now on chapter 5.5. We are going to now learn how to write out formulas for ionic compounds. So write an ionic compound. In order to understand this, review the elements that form ions with predictable charge. These are the main group ions. This means that if you look at a periodic table, look at the top, it says 1A or 1, and it'll either go 1 to 8 or 1 to 18. If it has an A, these are main group elements. These do not have different variable charges. They have one charge, meaning they lose a specific amount of electrons, and when they lose it, they have a certain oxidation state. So calcium loses 2 electrons, it is Ca2+. Oxygen can take 2, so it has a negative charge of 2- on it. So this is what I mean. Understand these charges, and it will make this part of this section a lot easier to understand. Ionic compounds, and in the middle where it says B, those are transition metals. They do not follow any particular rules, so right now we're going to avoid talking about them until later. Ionic compounds always contain positive and negative ions. That's the attraction that holds them together. In the chemical formula, the sum of the charges of the positive ions, which are cations, must always equal the sum of the charges of the negative ions, which are anions. So basically, when you look at a compound, for instance, sodium chloride, if you add up the charges, the positive and the negative, overall the compound is still 0. They have to cancel out. So that's what this bottom part is. Okay, so here are some charges, and you can see group 1, and if it's an A, which I have titled there, A, main group elements, they have a specific charge. And how do you know the charge? Well, for here, you're just looking at it, and it should match. Group 1 loses 1 electron, group 2 loses 2. Don't pay attention to the B's. Here's a 3. Aluminum will lose 3. Now we start getting into some of the other ones, so we're not going to look at these bottom ones. But group 5, nitrogen has 5 electrons. It can take 3. That makes 8, an octet. Here's another one that can take 3. So both of these have 5, but they can take 3 more to fill an octet. Oxygen has 6 valence electrons, but it can take 2 more to fill an octet. And because remember, it takes as many as it needs to fill in that noble gas configuration. So halogens only need 1. Okay, so how do we write these out? We're going to use sodium chloride. Sodium chloride is a group 1. Sodium's a group 1, so it loses 1 electron. Chloride is a halogen. It is a group 7, so it takes in 1 electron. So when the transfer of electrons happens, you can see it would have a cation and an anion. Now make the magnitude, the number value, we're not looking at the positive or negative sign, of the charge on each ion. It becomes a subscript for the other ion. So this is where we're going to crisscross. We're not looking at the charges now, looking at the values, the numbers. We're going to crisscross these across into subscripts for the other atom or element. But if it's a 1, we do not write 1 by default. It is implied that it is a 1. So when we see sodium chloride, you would normally write it like this if it wasn't a 1, but because it is a 1, we write it like this. Now, if it was subscripts like a 2 and a 2, we would then reduce these down. You must reduce when you're dealing with ionic compounds. We do not leave them with numbers that can be reduced. If this is a 2 and a 4, then you reduce both by 2. So you check for that. And then the last thing, make sure that the charges cancel out. This is bothering me because I forgot a parentheses. So a +1 for the sodium, a -1, it equals 0. It sums out. It is good. Now what is this crisscross method I'm talking about? This is exactly it. You put that charge on the opposite atom. So in this case, aluminum has a plus charge of 3. Oxygen has 2. So instead of balancing it out like this, excuse me, I just sneezed. Instead of balancing it out by adding the charges, which you should still do anyways, just to make sure that it's correct, it tends to work itself out by just crisscrossing it. So in this case, we have aluminum. You now add it to the oxygen. We have the 2 on the oxygen, and we add it to the aluminum. And this is, so if we had to sum this up, this is 3 times 2 is 6, but it's positive 6, but we're adding it together. And this is 3 times -2 is -6. So positive 6 plus -6 is 0. So it balanced out without us even having to do anything. Now it gets a little complicated because now we have a 2 and a 2. And if you go back to rule number 3, you have to reduce subscripts, and people forget to do that. And then it makes it harder because it's implied and you have to remember what I'm talking about. So I'm going to show you exactly what this means. So we have magnesium oxide, but we have a 2 and 2. That needs to go away. We don't keep 2 and 2. So you reduce it down by dividing both by 2. And now it is magnesium oxide. Now here's the confusing part, that this is where in chemistry you just have to know these things. This means 2 magnesium and 2 oxygen. This means here 2 magnesium and 2 oxygen. Just because it was reduced down does not mean that this doesn't still exist. It absolutely does. This is that fun game about chemistry that a lot of things are implied and you're just supposed to know. All right, so let's do some examples. We have nickel 2 sulfide. So the nickel 2 right here, this implies what this oxidation state is on it. And sulfide, we should know where that is. It's under oxygen. And so it's got a valence of 6 electrons, and it needs 2 more to make an octet, so it contains 2 electrons on. Okay, we're going to crisscross these. So they're crisscrossed, but instead of being nickel with the 2 and sulfur with the 2, we reduce it down. It is still nickel 2 sulfide, but we write it without the 2's on it. Yes, this is something you will need to know. But very simply, look into if it's an ionic compound, you crisscross. Can you reduce? Yes. Can you reduce? No. Then you're done. Zinc chloride. So here we are. We're going to take these values and we're going to, again, crisscross them. This is a 1, so we don't need to write anything here. There's a 2, crisscrosses, put a 2. And now if we wanted to check the sum of these, this is 2. Let me do this again. Sometimes even I get confused. This is a 1 with a 2 charge, so that's plus 2, but now we have a 1 charge with 2, and that's negative 2. So 2 minus 2 is 0. All right, so again, this front part here with the parentheses, there's no space in between. This means plus 3. So iron 3. Now we have oxide, which is 2, and we're going to crisscross these, and we do. And this is iron 3 oxide. So this is the crisscross method. Now it gets a little bit more complicated, because this is what I was talking about, polyatomic ions. We have to keep these together as a group. So we may need to use parentheses in order to do the crisscross method, which we do. And it helps, like I said, you need to memorize these. By memorizing these makes your life 110% easier, because we will always use polyatomic ions no matter what chemistry you go into. And we use them more the harder the chemistry is. All right, so write a formula for the compound that forms calcium and nitrate. So nitrate is, hopefully it's on here. Here it is. Nitrate's right there. Okay. So first things, write the symbols and the charges. Make sure you write the symbol and the charges. Have to have both in order for you to visually see what you're working with. Now, use the charge as a subscript on the other ion. So we're going to flip these. So don't get caught up on the positive and negative charges. Just flip the values. So this is a 1, this is a 2. I'm ignoring the positive and the negative. Add them together. I'm only using a 1 here for clarity so you can see what that would look like. But now, with the 2, we can't put a 2 on the oxygen. We have to do this as a whole group. So this is where the parentheses start coming in to show that this is an intact group and it has to stay intact. So now we check, can we reduce it down? We cannot. We can only have whole numbers. So nothing can be reduced. And now let's verify the charges. And here is actually what it looks like without the 1. This is calcium nitrate. So we have a 2 charge with 1 calcium, and we have 2 with a negative 1 charge of the nitrate. 2 minus 2 equals 0. We are good. This is the same steps for everything that we work on with main group elements. It doesn't change. It just, you can confuse yourself if you get caught up with the negative and the positive. But as long as you know the value of those charges and follow the crisscross and reduce, you're fine. Okay, so now we have transition metals or transition elements. And that is this lovely section here. And as we start getting into it, they have different oxidation states. That's what we call these. All of these do. Very few do not. Silver's one that doesn't. Zinc is another one that doesn't. Aluminum, I think, is one that doesn't. And then the rest all do. So there's very few that don't. And how do we know which one? Well, we don't. There's no set rules, unfortunately. There really isn't. So you have to solve another way. And during an exam, you wouldn't be given that periodic table with the charges. These are things, again, the fun things that you just have to know the rules. So here is a problem from a transition metal. And it's asking to know the oxidation state of the transition metal. And you can very well determine it without a periodic table. So some metals can form ions of different charges in different compounds. Deduce the charge of the chromium ion. So how can we do that? Well, we know the charge of the nitrate. This is supposed to sum up to 0. So if we solve for X, which is chromium, we can determine its oxidation state. So here it is. Here's our nitrate with a -1. Here's our chromium that we don't know what number it needs to be. Solve for X. So pull out what you know. We have 3 nitrates that are -1, and this is equal to 0. So if we don't know what this one is, so this ends up being -3. So chromium minus 3 equals 0. Take that to the other side, and chromium is a 3+. That means that this is chromium. Oh, that should be a plus and not a star. Sorry about that. It should be a 3+. So the C is the oxidation state for chromium. We didn't know what it was, but we can solve it knowing that everything has to equal 0 in the end, even if there's charges. Okay, and that's it.